Now, I have talked on and on and on about conductors and insulators, but am I actually correct? I might just be आग बंद करके तीर चला रही हूँ, but we can actually test it, and we can test it with a tester. Yeah, that's actually its name, a tester. So it's pretty self-explanatory. Its only job is to test whether an object is conducting or insulating. So basically, you take this tester, you connect one of its parts to a cell or a bulb, and the other part to the object which you want to find out if it is conducting or not. So for example, I attach it to a metal cap made out of steel. Then what will the bulb do? It will glow. But what if I attach it to a wooden stick? It will not glow. And the same thing can be done with liquids. For example, we can take a solution of distilled water. We put in a cell, we put in all of the other things we need, but it will not glow. And the reason is distilled water is not a good conductor, and that is because before we had learned that good conductors are usually acids, bases, or salts, and distilled water, which in simpler terms means pure water, has none of those. It has no nutrients, no impurities, no salts, so it has nothing to conduct. That's why it's an insulator. On the other hand, if we use tap water, now that is a conductor because it has many impurities, and in this case it comes in really handy. And you might be wondering what are some other liquids that are also conducting. Well, some easy ones off the bat are lemon juice and vinegar because they contain acids, and acids, as we learned, are conducting. And some non-acidic liquids are milk. Now milk, if you consider it, it does contain acid, but it only contains acid in the form of curd, and that is also known as lactic acid. But even without the lactic acid, it still has many impurities. Unless you're straining and boiling it, it still has many impurities and many salts. That's why even before turning into curd, it is still a good conductor. And don't get me started on curd because that is an amazing conductor of electricity. Now we can use a magnetic compass to help us show this. So for example, we'll dip the two ends of a cell into lemon juice. We'll connect one of them to the magnetic compass and one of them to the cell. Now this magnetic compass will its needle will show deflection. That is because of the magnetic effect of chemical. And we have two other effects as well: heating, magnetic, and I forgot the other one, but the heating one is pretty simple. It's the one that we do with the bulb, and basically the power outage gets too much and it heats up the filament, which then heats up the bulb. And if the bulb is too hard to glow, you can use LEDs. They are a really simple switch out which require a lot less electricity than bulbs. So if you enjoyed this little experiment that I told you guys today, make sure to hit that subscribe button because I post videos like this daily, and who knows, maybe I'll see you in my next one.